Hello, class. Welcome, welcome. Hello. Glad you could join me. So I'm going to work the printed version of test number 2 review that was generated for me. And everyone should be similarly working their version, earning a 60% or higher to be eligible to take test number 2. And so the idea of me doing this will hopefully help you understand how I want you to show your work. You always want to be able to show your work to support your answer choices and your answers. And so this will give you an idea of how to do that. Okay, so welcome and thank you for joining. All right, so let's get started. This is for the Math 1332, the Liberal Arts Math 1, okay? So the first problem that was generated for me looks kind of like this. It's having us identify a pattern in this given list of numbers. And so generally on a test, when you input your answer, you want to identify the number that's generated. But then on your test paper, I want you to also write a justification and explain, exactly what's going on in the pattern that you're noticing. Okay. And so I'm going to write my work on my own paper. And so if I look at this problem number 1, I have 1/7, 1/11, 1/15, 1/19, 1/23, and then I've got a blank for my answer. And then the computer is going to want you to answer the next number is, and then your instructor will also want you to describe the pattern. So you can start off saying something like, the pattern is, all right. And so when you look at this problem, notice how in this problem you've got fractions, and notice how the numerators are all the same. The numerators, which are the top numbers, are all 1. And on the bottom, all the denominators are changing. And let's see if we can figure out a pattern as to how the denominators are changing, because it might be that the next number might be another fraction where you'd have 1 in the numerator, okay? And then you just need to find the denominator. So sometimes the pattern might be that they're adding the same amount or subtracting the same amount, or maybe dividing the same amount or multiplying the same amount. Because we have 4 basic operations in math. And so that would be a good start for us. So if I study these denominators, the first one is 7, second one's 11. If I just notice the difference, if I look at the difference on that, 11 minus 7 is 4. And so you ask yourself, are they possibly, to get from 7 to 11, are they possibly subtracting the same amount? And you're going to nod your head and say, no, because to get from 7 to 11, it has to be an increase, not a decrease. And so let me go ahead and if I try to add that amount, let's see. So I have 1/7, and let's say I were to add to 7 4. 7 plus 4 is an 11. So you see how that actually does match the second fraction? Okay, so maybe the difference here is helping us. 11 minus 7 is 4, but then because there's an increase, actually here, instead of decreasing here, you would add. 7 plus 4 is 11. And if we think the pattern is adding 4 to the denominator, we can test that. If we look at this 11 and 15, so again, 15 minus 11, that is 4. So then when I come over here and I look at this next fraction, 1/11, so I take the denominator 11 and I add 4. That does give me 15. Okay. So it looks like what they're doing, it looks like the pattern is that they're adding 4. So 7 plus 4 is 11. 11 plus 4 is 15. And then 15 plus 4 is 19, right? So 15 plus 4 is 19. And then 19 plus 4 is 23. And then 23 plus 4 is 27. So it looks like the next number is going to be 1 over 27. And we can describe the pattern as something like the pattern is adding 4 to the denominator. I'm going to put plural. So it looks like the pattern is adding 4 to the denominators, okay? And also we're leaving, what about the numerator? And leaving the numerator as 1, right? Because we did do something in the sense of the numerators, we did leave it as 1. We just didn't write 27. We wrote 1 over 27. So you're just writing down the pattern. What are you doing when you write your answer? What the next number is? We're leaving the 1. The numerator is 1, and what we're doing to the denominator is we're adding 4. So just something to that effect. Okay. All right. So now if we look at let's look at number 2. I'm not sure if you could have seen what I was writing there. How I was adding 7 plus 4, which is 11. 11 plus 4, which is 15. 15 plus 4, which is 19. 19 plus 4, which is 23. And then 23 plus 4, which was 27, okay? But I did start off with subtracting, right? I did start off doing 11 minus 7, which was 4. 15 minus 11, which was 4. So then, and then I started saying, okay, let's add 4 to the denominator, okay? So there's some work there to justify our answer. So what you don't want to have is just an answer choice and no work to support it. That's for sure. Okay, so you've got to support it with some kind of work and describe your pattern. Okay, now if you look at number 2, it looks like number 2 is a rounding problem. How are y'all doing with rounding? So some of our classes, we round the entire semester. Like for example, in a statistics class, we're continuously rounding throughout the entire semester. So especially chapter 4, we work with probabilities. Chapter 6, we're working with areas under the curve. We're rounding. Very beginning of the semester, we're also rounding when we do evaluates finding some p-values. We have to round to compare in our initial quiz number 2. So in some classes we round the entire semester, like for example statistics. So in this course we are rounding for test number 2. So according to the survey, look at all these people we have. So we have in your periods, this is like your ones periods, hundreds, right? Ones, tens, hundreds, thousands, 10,000s, 100,000s, and then millions, okay? So we have these periods, and I do have a little chart I can show you here. Here's our decimal point. So I was saying this is the ones period. So it's 1, 2, 3, comma on the large side, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. So that's what I was saying. That's like the ones period, one group of 3, and then the thousands period, and then the millions period. Okay, and you can see on the side here, can I turn it on the side? We have ones, tens, hundreds. Okay, and then into the thousands, 1,000s, 10,000s, 100,000s, and then we get to the next period, which is millions, millions, 1 millions, 10 millions, 100 millions, and then sometimes we'll go past that into the billions. So billions, 1 billion, 10 billion, 100 billion. Okay, and so that's what we've got. This first period is the ones period. This is the thousands period. And this is the millions period. Okay. And so we're rounding. And also what you want to notice is that on the large side, here's your decimal point. So on the large side to the left of the decimal, these all in S's. But on the small side, so on the right side of your decimal, these all end in THS, THS. And we never write commas on this side, on the small side. On the decimal side, we don't write decimals. And so also on the right-hand side, the small side, notice how it doesn't start with ones on this side. Notice how it starts with tens, hundreds. So if you're rounding like money, round to the nearest cent. The nearest cent is the hundreds place, because after 99 pennies, you have one more penny, you have $1, $1.00. So tenths, hundreds. So that's why this side we start with tenths, hundreds. If you think of pocket change, 99 cents. Okay, and so in your rounding, let's see, you might have some decimal place values to round to, and you might have some large side on the left-hand side of your decimal point. So if I just check this out, I'm checking to see if I have I'm looking for THS. Do I have any THSs? Because if I have THSs as decimal side. So see, there's no TH here, no TH here, no TH here. So yeah, so this looks like these are all going to be numbers that we're comparing on the large side of the decimal point. Okay, and so and if we were rounding THSs, then we'd have to use this place value. Okay, so in the past, I have included like on the template that I used last semester. This is kind of a light template here, but you can see on this problem 1, I made this problem number 1, for example. You can see I included the template, and then this is for students to show their work. And this just happened to be on the first page for this test that I used, for example, last semester. And so I usually do that. We'll include this on the test template, okay, and to aid the students with their work. Okay, so it's built in. And so so for this problem here, the way you would use that template is, for example, let's say we're going to work with this number. So again, your periods is the ones periods, the thousands period, the million period, and the decimal, if you don't see it, it's hidden in the back. Okay, so let me see if I can increase this. So if I write that number down for the problem that I was randomly given, so towards the end I have this 555. Here's my decimal point. Yeah, so let me just put my decimal point on all these, because so I won't get confused. Sometimes if you leave that blank, you might accidentally put a number in that cell there. So I'm going to put a decimal point. That's where my decimal's at. But at the end, I see these, I work backwards, this 555, 182. And then I see that 65. There we go. So you see I'm jotting down the same number that was given to me here. So 65,182,555. Okay. And so I'm rounding to the nearest hundreds. So the nearest hundreds, I box my hundreds place. This is ones, tens, hundreds is right here. And I look at the number to the right, and I want to see if that's 5 or more. If the neighbor is 5 or more, then you have permission to increase the box digit by 1. And so we have permission to increase this 5 into a 6. And what happens is the remaining digits become zeros. And sometimes you can leave them off. If you're on the decimal side, you can leave them off. But you don't want to leave these off because you need these. This in the ones place and the tens place, these are going to become zeros, and you do need them. So sometimes the digits to the right of the box digit zero out, they become zeros, and then you record them as needed. So these do need to be recorded. You don't want to lose those place values, okay? And this will become a 6. And then these will remain the same. Sometimes the digit in front, it might also increase if you're carrying, like 9 and 1 is 10. So this had been a 9, 9 plus 1 is 10. Then you write down the 0 and then you carry the 1. So sometimes these can get changed to the left of your box digit if you've got 9s and you're having to to carry, because 9 and 1 is 10. So sometimes actually, if this starts off, like if this had been a 9 and you're carrying 9 plus 1 is 10, so you write down the 0 and you carry a 1, and then 2 plus 1 is 3. So sometimes this can increase, and it has to do if you have a box digit that has 9 and then your neighbor is 5 or more, so then you do have to add 1 and then carry. 9 and 1 is 10. So sometimes it happens. So in this case, this isn't happening here. Here, the neighbor is just 5. 5 and 1 is 6. So this will become 6, and these right here, these 5s right here, will become zeros. Okay. So I'm gonna kind of jot that down. So the idea is that with borrowing, or excuse me, the idea is that with rounding, when rounding, so what you do is you have to ID. So I say you box, ID. So you box the place value digit that you're rounding to. Okay. So like a while ago, I was rounding to the nearest hundreds, ones, tens, hundreds. So I boxed the 5. So when rounding, you ID or you box the place value digit that you're rounding to, and then you study its neighbor to its right. So I did this, box this, and had an arrow. And then it's an if-then statement. If-then, you're comparing. So if there was a digit here, right? So if the neighbor is at least 5, and it was in our problem, the neighbor was at least 5. So if the neighbor is at least 5, then we're supposed to add 1 to the box digit. So you're supposed to increase this by 1. But otherwise, meaning that if the neighbor is not at least 5. So at least 5 means, is it 5, 6, 7, 8 ellipses, dot, 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 right? And actually it wouldn't get any bigger than 9. So is the neighbor 5 or more? So is it 5, 6, 7, 8, or 9? Because if it is, then you're going to add 1 to your box digit. But otherwise, if it's not 5, 6, 7, 8, or 9, otherwise, if it's not, then don't increase, I'm going to underline, don't increase the box digit. Okay, so box digit remains the same. Okay, so if your neighbor is a 4, a 3, a 2, or a 1, or a 0. So otherwise, then don't increase the box digit. Box digit remains the same. And again, it's because the neighbor is either a 0, a 1, a 2, a 3, or a 4. So that it's small, right? All right. And then regardless of whether you have to increase the box digit or not, regardless, the remaining digits after the box digit become zeros. Okay. So the remaining digits after the box digit become zeros. Okay. And then you'll record the zeros as needed. You want to record them so that you don't lose your place value. Okay. So if you're on the decimal side, the THS side, then you really don't need all those decimals. You just want to make sure you hold your place value. So when they round to a certain value, you have to record your answer to that place value. Okay. So regardless, the remaining digits after the box digit become zeros. Okay. And then for the most part, the digits in front of the box digit, for the most part, the digits in front of the box digit remain the same unless there's carrying involved. Because if you have a 9 here on your box digit and your neighbor happens to be like a 6, and then you do this and you add 1 to that, then 9 and 1 is 10, and then you carry the 1, and then 3 and 1 is 4, and the remaining digits zero out. That becomes 0. And then usually we use a symbol. This is the symbol for, this is the symbol, which you would put the symbol on your own paper. I don't think the computer will let you put that answer choice in there. So that's part of showing your work. Put that symbol on your paper. So the symbol for rounding is the approximately equal to. Looks like that. That's a courtesy. It's a courtesy to let the reader know, like, look, this number wasn't exactly like this. This number was something else, and then you approximated it, you rounded it off. So it's a courtesy to let the reader know that it wasn't exactly this to begin with. So it's a courtesy. Okay. All right. So then when I go back to my problem, go to the problem again. So remember we had 65,182,555, and we were rounding to nearest hundreds, they said. Ones, tens, hundreds. We look at the neighbor, is that 5 or more? Yes. So increase the box digit by 1. So now this becomes, and it might be easier if you write it like this instead of on the side. It might be easier if you write it like that on your paper. This is approximately, so 5 and 1 is 6, and these become zeros, and these actually will stay the same. And then it's 1, 2, 3, comma, 1, 2, 3, comma, okay? So this is rounding to the nearest 100. Okay, so now we've got the same number. It looks like they're working with the same number, but now they're rounding it to the nearest 1,000, the nearest 1,000, okay? So if let me see, I have 1, 2, 3, 4, 5, 6. So if I skip every one, 1, 2, 3, 4, 5, yeah. If I skip every one, I have space to skip. So I've got the same number. But now I'm rounding it to the nearest 1,000, okay? So ones, tens, hundreds, thousands, okay? And look at the neighbor to the right. So ones, tens, hundreds, thousand. Look at the number to the right. Is that 5 or more? Yes. So you're supposed to increase this box digit by 1, okay? I'll write that on my paper. Okay, so in this one, we're rounding it to the nearest thousands. Ones, tens, hundreds, thousands. And then look at the neighbor to the right. Is that 5 or more? Yes, so add 1 to that. So now this is approximately 2 plus 1 is 3. These become zeros. And you do need them, they're place values. If you don't write them and don't record them, then you're losing those place values, ones, tens, hundreds. If you don't write them, then what happens is this will have to serve as the ones place value. So you don't want that to happen, because then you're going to decrease the number. And so 2 plus 1 is 3, and then these will just remain the same. Okay. So this is 65,183,000. Okay. Okay, then we're rounding to the nearest 10,000s. So I go back to this and I skip a space. And you can see here, there's 10,000s, okay? So this is, let me see if I can decrease this. Okay, so this is, and I can use my ruler. So that's ones, tens, hundreds, and then this is thousands, 1,000s, and then see tens, 10,000s. So we're going to box this 8 here. Okay, and then you look at the neighbor to the right. Is this 5 or more? No. So this is going to remain. This is going to remain. You're not going to increase it by 1. That's going to stay an 8. Okay, so then if I come over here and write that number down again. So ones, tens, hundreds, thousands, 10,000s. And then look at the neighbor. So let me just fix this one so too close. Okay, so then is this 5 or more? No. So this 8 remains. Okay, so I have approximately equal to this 8 remains. Now these, again, digits thereafter become 0. So this becomes a 0, and these 5s become a 0. And then these will remain, will stay the same as well. Okay, so you have 65,180,000. Okay, and if I just change my ink a little bit, and I'm going to write down that number again. Okay, so after the 10,000s, now we're rounding to the hundred thousands. Okay, so again, this is ones, tens, hundreds, thousands, so 1,000s, 10,000s, 100,000s. So we're boxing this one right here. Ones, tens, hundreds, thousands, 10,000s, 100,000s. And you're looking at the neighbor. Is that neighbor 5 or more? Yes, it is. So add 1 to that. Okay. So now this becomes a 2, and all of these behind it become zeros. And these will stay the same. Okay. So I'm going to write that number. And this was 100,000s. Ones, tens, hundreds, thousands, 10,000s, 100,000s. Look at the neighbor. Is it 5 or more? Yes. So add 1. This is approximately, so this 1 and 1 is 2. These become zeros. And this will stay the same. Okay, next we're going to round to the nearest, after the nearest 100,000s, we're going to round to the nearest millions. And then the last one will be the 10 millions. So let's do the millions. Okay, so I'm going to write down the number again. So this is ones, so you can see ones, tens, hundreds, thousands. So this is the 1,000s, 10,000s, 100,000s, and then you can see right here that this is the millions. Okay. You can see millions right there. One's million, 1 millions. Okay. So we're going to box this 5. And you can look at the neighbor. Is that neighbor 5 or more? No. So this is going to remain the same. This remains. These will become zeros. This will remain, and then this is going to remain also 6. Okay. There's your millions. Then you look at the neighbor. So ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. Is the neighbor 5 or more? No. So this remains the same. Okay, so we have 6, 5. This also remains the same, and these become zeros. It's approximately on your paper. We've got 65 million. Okay, and then again, I'm going to write that number down. It's the same number that we've been comparing. Excuse me, let's see. And this time we're rounding it to the nearest 10 millions. Okay, so ones, tens, hundreds, thousands, 10,000s, 100,000s, million, 1 million, and then 10 millions. Then you look at the neighbor. Is that neighbor 5 or more? Yes, it is. You're going to add 1 to that box digit, and then these digits thereafter become zeros. Okay. There's 10 million. So ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. Oops. And 10 millions. So we want this one. Ones, tens, hundreds, thousands, 10,000s, 100,000s, million, 10 million. 5 or more, yes. So add 1 to that. And so now this would become approximately, this is now a 7. This is a 0, and these are all zeros. Okay. All right. Like that. Answers. Okay. All right. So that was number 2. So on your, when you take your test, like you may not have, this one we had 1, 2, 3, 4, 5, 6 parts. I mean, you may not have a problem that's got 6 parts like that. And so, but it just depends how it's set up, you know, on my, when I work on the test options. So I'm just not sure what will be available in my test bank, right? So I'll have to take a look at that. Okay, but definitely you're going to have something related to rounding. It just may be one problem that you're rounding. I'm not sure how many parts it will be, but it will be something related to rounding on the test. Okay. Okay, now let's go to number 3. So this says determine the following estimate without using a calculator, and then they want you to use a calculator to perform the computation necessary to obtain an exact answer. And then how reasonable is your estimate when compared to the actual answer? Okay, so let's say we lease a car at $503 per month for 4 years. Estimate the cost of the lease, and they're telling you they want you to estimate by rounding the monthly payment, which was at $503, round that monthly payment to the nearest hundreds. Okay, so then we'll have to follow the directions. So number 3, and we're doing the estimate part. Okay, so you have 503. And they're saying they want you to round that to the nearest 100. Okay, so ones, tens, hundreds. And then look at the neighbor. Is that neighbor 5 or more? No. So this will remain a 5. So then this is approximately 500. Okay. So this is going to be $500 per month. Okay. And then you're renting this or leasing this for 4 years. So then we also have 4 years, and there's 12 months. In a year. Okay, so 4 times 2 is 8, 4 times 1 is 4. Okay, so then for our estimate on the cost, we're going to take 500 times 48. Okay, and so you can use, at this point you can use your calculator. You're showing your work, you're showing your rounding, and you're showing how you got the 48. And then at this point you want to use your calculator, you can do that. I will show you how to do the multiplication just in case it's been a while, you don't remember how to do that. You would say 8 times 0 is 0, 8 times 0 is 0, 8 times 5 is 40. And then when you do the second row of multiplication, this needs to either you leave it vacant or you put a 0 or you exit out. And you leave that vacant because it's like a placeholder, because see, you're going to start multiplying by 4, which is in the hundreds place, see? So you want to start recording digits right here. So 4 times 0 is 0. So you see you got to leave that space vacant. I exit out. But 4 times 0 is 0. 4 times 0 is 0. 5 times 4 is 20. And then you just start adding everything up. And then this is money. And it's, remember I said 1, 2, 3, comma, 1, 2, 3, comma, okay? And so it looks like it's gonna be about, the estimate is gonna be about 24,000. So it says the estimate of the total cost of the lease is approximately round to the nearest hundreds as needed. So you do that at the very beginning here. Round this at the very beginning, hundreds. And we get this here. So as I said, rounding the monthly payment to the nearest 100. Okay. So then that's the first part. That's the estimate. Oh, and then of course if I use my calculator, I'm doing 500 times 48, which is 24,000. Okay. Okay, and then there's a second part. Let's see. How reasonable is your estimate when compared to the actual answer? Okay, so then they also want the actual cost, the actual cost. So then you change my ink, you just go back and now you do the actual cost. So first it was the estimate, now it's the actual. So then the actual, you would take the $503 times the 48. So you don't need to show 12 times 4. You already did that up here. You showed your work. So then, and then you just take 503 times 48, and that's going to give you $24,144. And then there's a third part. It says, how reasonable is your estimate? And then for that, they kind of, usually, you'd write a sentence. It looks like they're kind of guiding you here. It says your guidance, or do we say that the estimate is a little bit higher than the actual result? Or the estimate is it a little bit lower than the actual result? And then they actually want the difference, okay? So for us, our reason was our estimate. So our estimate was 24,000 and the actual was 24,144. And when you're comparing it to the estimate, So for us, the estimate, which is 24,000, is a little bit less. It's a little bit lower. So the estimate is a little lower, a little less than the actual. And then they want the difference by how much. So you want the difference. So then you would say, okay, I'm going to do 24,144 minus 24,000. Then subtract that off. 4 take away 0, 4 take away 0, 1 take away 0 is 1. So that's about 144. This is a little bit lower. Okay, then we go to problem number 4. So let's see, this says one more piece of information is given than is necessary for solving the problem. Identify this unnecessary piece of info, then solve the problem. So let's see, an architect is designing a house. The scale on the plan is 1 inch is equal to 4 feet. If the house is to have a length of 60 feet and a width of 52 feet, how long will the line representing the house's length be on the blueprint? Okay. And then they have answer choices for the first part. What piece of given information is not necessary to solve the problem? And then they say the line representing the house's length will be blank inches on the blueprint. Simplify your answer. Okay, so let's see. What I did on my paper just to show work, I created like a rectangle to represent the house. And it said that the length was 60 feet. And it said that the width was 52 feet. And we also knew that on your blueprint that, let's say this represents 1 inch, that 1 inch would actually represent 4 feet. So I did that as well here. And then I actually started dividing my dimensions by 4. So I took my 60 feet and I divided by 4 feet. So on my calculator, and you see these feet will cross out. So 60 divided by 4 is 15. Okay. And then, let's see. The other thing I did is I went ahead and showed I went ahead and did the 52 divided by 4. And 52 divided by 4 gave me 13. Okay. And let's see, I also jotted down that I also jotted down, just so you could just think about area. I also jotted down that, area happens to be length times width. So I also made a note to myself. The area is length times width. Okay. And then I said here that the line representing the house's length will be 15. So that line, it says, this little line, that 1 inch is equal to 4 feet. So for us, our line representing the house's length is going to be 15. You would need 15 of these little lines to show that it's actually 60 feet. So I did make a note of that. And let's see. So let's see. Yeah, because they say, how long will the line representing the house's length be on the blueprint? Yeah, so this is answering that question. The line representing the house's length will be 15. Okay. Yeah, and this is going to be 15 inches. It's going to be 15 inches. Because remember, these feet crossed out. And so it's made 15 inches. See, 1 inch is 4 feet. Okay. Now, as far as, so I actually did that first, and then they said, what piece of info is not necessary? And then if you look at the choices here, let's look at the choices. They have an A through D here. They say that the length of 60 feet, well, we need that because they were asking for the house's length. So that's a keeper. I needed that. 60 divided by 4 was 15. So that's a keeper. The scale is 1 inch equals 4 feet. Well, that's important. I need that. I need to know what my scale is. That's how I knew to divide by 4. So I can't lose that. Then I won't know what to divide this by. So that's important. That's a keeper. And it says that the width of 52 feet, the width of 52 feet. So I did use that over here. 52 feet divided by 4 was 13, okay? But I didn't really need it to solve this problem. I just did this extra work. 52 divided by 4 was 13. If I wanted to know the width, the line representing the house's width would be 13, okay? But I didn't really need that. And then it says also the area of the house. Well, you see, that's why over here I wrote area. Area is equal to length times width. So that's a keeper. You do need the area, because area, if you know the area, you know the dimensions of the house, you know the length and the width. So if we weren't given, if we didn't know the area, then that means we wouldn't have been given like the dimensions, the length or width. So we would, from our choices, we would say between C and D, the best one to keep, I would say, would be D, because without the area given, you wouldn't have the length known and you wouldn't have the width known. And you definitely need the lengths. You need that dimension. So yeah, so the best one to say to rule out, not necessary, we could say would be the width of 52. Okay, so what piece of info is not necessary? And then we'll argue that it's the width of 52 feet. Okay, so I'm going to put a star here on area, because area is length times width, and the length happened to be A was equal to 60 feet times 52 feet. So that's why you need that dimension, because without that dimension, you wouldn't be able to calculate the area, and you wouldn't have had the 60, and you need the 60. You would lose the 60. So 60 times 52 happens to be a lot of square footage, 3,120 feet square. It's a lot of square footage, yeah. So you know, with taxes, when you have a home, you get charged every year for your square footage living space on your home. So you have to pay so much dollar for each square footage, right? And so, like, let's say, I'm just saying, what if it were $5 per square foot that they would charge you? So that's a lot. You're paying 15,600, and I don't think they would charge that much, depending on the neighborhood and just like the area that you live in. But yeah, usually people, I think, generally could pay at least, well, I guess it could vary, right? Depending where you live, Dominion, Alamo Heights, okay, different parts of the city, South Side, North Side. So yeah, it probably could run, it does run in the thousands, at least I would say 5,000. So let's see, if it were $2 per square foot, then you're paying that much a year, right? Per square foot. And of course it depends on the size of the home. So that's a large square footage in the 3,000s. Yeah, so just keep that in mind. You're buying or building a home, you've got to pay every year for that square footage of living space. It's a requirement. All right, okay. So that's number 4. Okay, now let's go to number 5. Five says, determine if the collection is not well defined and therefore is not a set. And they have the collection of United States museums. Okay, so they want to talk about the definition for well defined. So let me write down something, what I have from my notes for well defined. So I'm going to say that members of sets are well defined. Like, and here's an example, like the collection of football players who are Hall of Fame recipients, okay? And they're not, I'm gonna underline not, subjective from person to person. Like, here's an example of that subjective, right, from person to person. Like the collection of great quarterbacks. Okay, so when they talk about well-defined or not well-defined, something that would not be well-defined would be something that's subjective. Because, like, for example, of great quarterbacks, I think we could say somebody might think that like Joe Montana was a great quarterback, okay? Or somebody might think of say some of the older quarterbacks, Tony Dorsett, right? Is a great quarterback, okay? And so that will vary from person to person, just their opinion, right, of who's considered a great quarterback, okay? So that would be subjective. But if you talk about the football players who are in the Hall of Fame recipients, right, those go through a series, right, of surveys and opinions and voting and go through a committee. And so it's tough to get in, it's tough to get into a Hall of Fame, okay? Because they have to go through a process, right? So they're well defined, okay? And so that's kind of the difference between well defined and not well defined. So the not well defined is subjective, okay? So not well defined, right? It's varies from person to person because it's subjective. It's like their personal opinion, subjective, okay? But well-defined goes kind of through a process, a committee review, it's more strict, well-defined, okay? So here we've got the collection, for the example that was given to me, it was the collection of U.S. museums. Collection of U.S. museums. So they want a collection of U.S. museums. So if I think of United States museums, these are some of the ones that I put down. Examples of those would be like the Alamo was considered a museum. That's in San Antonio, the Institute of Texan Cultures. That's also in San Antonio. That's considered a museum. The McNay Art Museum. That's also in San Antonio. That's these are considered museums in the United States. Okay. Also, some like here's one in Washington D.C. is the Smithsonian. That's in Washington D.C. So although they're closed due to everything, due to the pandemic, although they're closed, they could still be open virtually. I believe they still have people, I think, joining in virtually. So if you're interested in doing that, can't take a summer vacation there right now, but you could probably join virtually to see the inside of the Institute of what they have on display, right? So you can check that out. It's an idea. Smithsonian Institution. And then I did put down one more. This one's in New York City. There is the Museum of Natural History. So that's the American, they call it American Museum of Natural History. So that's New York City. Yeah. And San Antonio, by the way, has about 33. In San Antonio, these are all in San Antonio. And these top ones, the Texan Institute, the Institute of Texan Cultures in the Alamo, that's those, there's actually about 33 in our city. I just listed 3. And then I picked one, Washington and New York City. But I would say by looking at the description, the collection of U.S. museums, these are just some U.S. museums, and there's many. And so, but this could be considered well defined. The collection, and I'll put ... because there are more, right, in the U.S., but the collection would be considered well defined. Okay, because we're not being subjective. We're not limiting them. So like here, when we went to the great quarterbacks, that can change from person to person on who they think is a great quarterback, subjective. But when we say a collection of U.S. museums, I'm not putting any limitations. We're listing all the museums, and there's thousands of them. These are just examples. These are just examples of them. But this collection is considered well defined. Okay, so we're not restricting that. It's not being subjective. Okay, there's more. See, ... There's more. I just put examples of some museums to think about. Okay. All right. So let's see. Let's look at number 6. So 6 says that they want you to determine whether the given statement is true or false. And they have this symbol. This means is an element of, is 24 an element of this set. Okay, so I'm gonna just put down some information about an element. So I'm going to say that an element is in a set if the element is a member of or if the element belongs to, so either is a member of or the element belongs to a set. Okay, and so they gave us the problem that they gave me that I printed, gave me this 20, 22, 24, 26. That's what I was given here. So for me, I can say that I see 24 right here inside this set. See that? So I'm going to say 24 for us, for this problem. 24 is an element of the set because it is a member. Okay. So it's an element because it's a member. Okay. So 24 is an element of the set because it's a member. Okay. It belongs to it. It's a member, comma. It belongs to a given set. Okay, so I'm giving an explanation also. Okay. So that way, so when you choose your answer, yes or no, true or false, yes or no, you provide a justification. So you provide a justification. You're explaining. This is where your vocabulary comes in. So I do want you to write a sentence on your paper to explain your answer. Is it true or false? But then you have to defend your answer. So you have to say something, and you have to say something about the definition of an element. So for something to be an element of a set, it's because that number is a member or it belongs to the set. So you need to say something to that effect, okay? Okay, so let's see. So the next, continuing with this thought, just to give you more examples, 7 and 8 are continuing with this thought. So if you look at 7, determine whether the given statement is true or false. And then, of course, I want you to justify it on your paper. So here it says, is 27 an element of this set? Okay, and you see how this one has dot, dot, dot? These are called ellipses. These are ellipses. So here, number 7, we have 27. It's an element, and I'm going to do a question mark on this one here. And I'm going to do element of 16, 18, 20, dot, 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 and then 34 and question mark. So these are called ellipses. So that means that there's more numbers in between 20 and 34. But now you have to see the pattern. So again, that's why the very first problem we did, you have to look at a pattern. So it looks like these are, it looks like this set is comprised of even numbers, right? It looks like they even numbers in a 0, a 2, a 4, a 6, or an 8. and also consecutive even numbers, like one like right after the other, consecutive even numbers, they increase by 2. So that looks like what's happening here. These look like they're even numbers, and it looks like they're consecutive even numbers, that they're increasing by 2. So you see, if I do 16 plus 2, that's 18. 18 plus 2, that's 20. 20 plus 2. So then that means I have this. 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. So you see how I fill those in? So that would be part of you showing your work on the test, right? That you know these 3 dots mean there's other numbers in the set, and these are the numbers in the set. And then you go back and say, okay, is 27 a member of this set? Does 27 belong to this set? And nope. No, it's not, because 27 is not even. Okay, so then here we would say that this is false, that 27 is not an element of our set. It's not an element of our set. Okay, and that's because 27 is not an element of our set. And why? Because 27 is not a member, since why? Since it is not an even number, right? 27 is not an even number. So why you don't see it in there? Why is it not in there? Why? Explain to somebody. Well, because it's not an even number. This is just a set of even numbers that begin with 16 and end with 38. So this kind of looks like this. Oh, and it's 34. It's actually 34. So it looks kind of like this. And see these little underscores? These little underscores, those are called underscores. And that means that you include, not exclude, but you include the endpoints. You include the endpoints, okay? You include the endpoints. Okay, so it's these are even numbers that include between 16 and 34 inclusive, right? Even numbers. So 27 is not an even number. Okay, so something to that effect to justify. Just don't say false and move on. You need to learn to support your answer choices. So you have to write something down, communicate that with your teacher, okay? Okay, so then number 8 is another problem related to this kind of question here. So determine whether this is true or false. So this says 13 is not an element of this set, and you've got these ellipses. So on your work, we should figure out what is inside these ellipses. That's part of showing your work. And then check out and see, is 13 a member of that? And then see if this is a true or false statement. It's saying that 13 is not going to be a member. So you got to show some work. So don't do it in your head. If you can do it in your head, that's good. But I cannot read your mind, so you have to learn to justify. write things down on paper to support your answer, so that somebody who's not in your head, right, they can see your work, go back and see your work and review it. So you're learning how to communicate mathematically, right? Okay, so 8, we have 13, and they're saying that's not an element of this set. 1, 2, 3, ellipses, dot, 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 and then 8. Okay, so then this would say 13 is not an element of, and I'm gonna put a question mark here. And same thing over here. I was gonna go back and put a question mark here too, because we're trying to decide that. Okay, so then I have 1, 2, 3. So these look like these are just consecutive integers. Or integers. Well, integers are positive and negative, so it looks like these are just, we can say consecutive natural numbers. That'd be better. Consecutive natural numbers, which are counting numbers, and they use this symbol n to represent that. You don't want to say whole numbers, because whole numbers begin with 0. Whole numbers begin with 0. Okay, so whole numbers start with 0, 1, 2, dot, dot, dot. So you don't want to describe these as whole numbers. You didn't start with 0, start with 1. These are counting. These are counting numbers. These are natural numbers, and they're consecutive. Consecutive means one right after the other. So consecutive means one right after the other. Okay, they increase by just 1. Okay, so this is 1, 2, 3, 4, 5, 6, 7, and then look, we stop at 8. Okay, so then this would look kind of like this then, from 1 to 8, from 1 to 8, and include that. Okay, so and I'm going to put a question mark because we're trying to see if this is true or not. So this is showing your work. You're telling me, you're communicating that you know what those ellipses mean is in between there. And now we're going to say, okay, 13, and then you're going to look for it, and yeah, see how it's not in there. So this is saying that 13 is not an element of our set. And then why? Because it is not a member. Okay. You can see it's not in there. It's not in there. It's not a member. And so is this true or false? Yeah, this is true. 13 is not, and that's true. That would be true. Okay, this is true. So I'm going to put true in a couple places in case, you know, it gets chopped off on the PDF when I make it a PDF. So I'll put in a couple places. Okay, all right. Okay, so now let's go to 9. Nine says, determine whether the set is a finite set or infinite set. So we have the set of natural numbers that are less than 6. Okay. Okay, so let me see if I can write something down about finite sets, and I do have, let me see, let me write a sentence here. So let me say that finite sets are sets that we can count and finish counting. So I like that definition. So finite sets are sets that we can start counting them, and we can actually finish counting them. Okay. So then infinite then means something different, right? Infinite means that we cannot finish counting infinite sets. I guess I can write that down there. Infinite sets or let me say this. We cannot finish counting an infinite set. Let me say that instead. We cannot finish counting an infinite set. So that gives you an idea about infinite and finite. Okay, so when I look at the problem that was generated for me, I have the set of natural numbers. Remember I gave you that symbol a while ago like that? Less than 6. Okay, so that would be something like this. Your x is less than 6, something like that. So that would be then if I do my set. And remember, I cannot, these are natural numbers. So natural numbers are, they don't start with 0. Remember, 0 are whole numbers. And you don't have any negatives because that would make it integers, -1, -2. You don't have that. So remember, natural numbers are counting numbers. They start with 1, 2, 3, and so on and so on. So we want the natural numbers less than 6. So that means we would start with 1. Let me make this better. This looks funny. So 1, 2, 3, 4, 5. But I cannot include 6. You need to leave 6 out because it said less than. Leave 6 out. Why? Due to less than. It didn't say less than or equal to. It didn't say less than or equal to. That would have been, it didn't say less than equal to. Okay, so that includes that endpoint. So it didn't say less than or equal to. So if it had, then that would have been 1, 2, 3, 4, 5, 6, less than or equal to. But it didn't say that. It just said less than. Okay. So don't leave out the 6. Okay, due to less than. Okay, so now we'll go back to, so you got the set written now, so you should describe your set. So this is our set. Our set is, and they didn't name it. they didn't name it. So if you wanted to name it A, you could. You could say A equals. That'd be fine. You want to name it something, or our set is. But you should identify your set from the description. The natural number is less than 6. Okay, and then now talking about, is it finite or is it infinite set? So can you count and finish counting? Yeah, we can count and finish counting. 1, 2, 3, 4, 5. Yeah. So this is a finite. This is a finite set. And then why? Because we can finish counting. And we will be counting from 1 to 5. Yeah. Okay. It didn't have something like the ellipses, dot, 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 that it continues forever, right? Continues where you never stop counting. It doesn't have that. Okay. So like it terminates. It terminates, okay? Our counting terminates at 5. To 1, 2, 3, 4, 5, and that's it. We're done. So this is a finite set. Okay, and then 10. Oh, and I was going to say while I'm at it, we talked about natural numbers and we talked about whole numbers over here. Whole numbers begin with 0. So I was going to put a script W. Sometimes you see that. It looks like Wonder Woman, right? W for Wonder Woman. So whole numbers. Okay, and then I was also going to somewhere put, it's probably a good place to put it. I've been talking about integers. Integers look like a fancy Z, like a fancy Z. That is integers. And integers are like the negatives, like, okay, so it's dot, 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 ellipses, -3, -2, -1, then 0, 1, 2, 3, dot, dot, dot. Okay, so those are integers. Okay. Just FYI, because the book will probably reference that throughout the course, so just remember what integers are, okay? So they're different from natural numbers, and they're different from whole numbers, okay? But those are good sets to know. Okay, so number 10 says, express the set using set builder notation. Use the inequality notation to express the condition X must meet in order to be a member of the set. Okay, so they have 32, 33, 34, 35, and then dot, 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 and then 58. Okay, and all right, so first let me say something about like what is set builder notation. Set builder notations. Okay, so set builder notations, you need to know that like their characteristics. So they begin and they end with those curly braces, which are kind of hard to draw. They look kind of like that. They're on your computer keyboard, right on top of the bracket. So right by the P. So right by the P on your computer, you have this bracket. They're right there. You have this bracket, and they're right there. So those are, you can get a good picture of your curly braces because they are on your computer keypad there. So they set builder notations begin and end with curly braces. So they're a little hard to draw. And then when you write it up, you write this. Usually it's an X, not all the time, but you write that. So this means the set X such that, I'm going to just say dot, dot, dot. I'm going to just say the set X such that. So that's, this bar means such that. And that's a secretarial, this is secretarial shorthand. It's like a secretarial shorthand. Yeah, so people who have secretaries, probably lawyers have secretaries, and I'm sure they still have a school for secretaries. They have to learn shorthand. So in mathematics, we do tend to borrow some of their shorthand notation from secretarial work. So that means that vertical bar, this vertical bar means such that. So that's in a set builder notation. And then you write your description. So you have the set X such that, and then you write your description, which usually includes the, like they're saying, the inequality. You write your description that will include the inequality here, and then you close it. Yeah, and then inequalities could be like less than or equal to, greater than or equal to. Okay, maybe you might have the equality, maybe, but for the most part, you're doing some kind of inequality, not so much an equality. I mean, I guess this is rare, but I guess it could happen. Something equality, I guess that could happen as well. Okay. So for us, though, so that's what it said. So when you look at your answer choices, you see how you can omit A right off the bat, because see how all these have X such that, X such that, X such that. So right away you can eliminate A because it says it's an element of the N. Okay, so then you have your set, which is 32, 33, 34, 35, dot, 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 58. Okay, so this doesn't take 5 grueling hours, but what you should do on your paper is you should figure out what goes in between here. So you're communicating with me. And you should try to pick something that doesn't have so many. Let's see. So after 34, 35, 36, you can see that these are consecutive, 32, 33, 34. So they're not evens, they're not odds. They're not increasing by 2, increasing by 1. Well, increasing by 2, increasing by 3. It looks like they're all increasing by 1. So this is 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, finally 58. Yeah, so usually on the test I try to pick one that is kind of lengthy, but it didn't take 5 grueling hours to do that. It probably took still under a minute, right, to do that. I usually try to find one that's not so spread out. But yeah, it was doable to show your work. It didn't take 5 grueling hours to do that, okay? So this is what our set is, okay? And now you want to build a set builder notation. So you know that in your set builder, you know you have to start it off with braces, and then sometimes you don't always use X. Sometimes you can use a different variable, but you can see that in your answer choices they are using X. So some variable X such that, and X, you can see that X is an element of the natural number. See, these are natural numbers. They're not integers. You didn't have any negatives. They're not integers. And zero's not in there. So 0 would be like a whole number starting from 0, 1, 2, 3. So it's not a whole number. So yeah, these are natural numbers. So we have x such that x is an element n. And then there are, in your description, you write your description that will include the inequalities here and will include the limitations. So it will include the limitations, your limits, like what are you limited to? So this looks like it runs from 32 all the way through 58. So it's sandwiched. It includes only the natural numbers, so not the fractions and the decimals in between 32 and 58, but you're limiting it to the natural numbers. So I know between 32 to 58, there are fractions in between them, there are decimals in between them, but we've already restricted it just to the natural numbers between 32 and 58 and including it. So that's why you want to use the underscore, the little bar. This little bar is a little underscores to include that endpoint. So we want to say something like this, 32 all the way to 58. And you want to close that. Okay. Yeah, and so this is less than this. See that point? See that that pointed figure, that pointed arrow points to the smaller number. So that's right. It's, in case you're wondering, why didn't I write it using this one? Because that one has an underscore. But see that point, then it has to point to the smaller number. 32 is smaller than 58. And we usually write things anyway, left to right. Usually left to right is smaller to bigger. Okay, so this is correct. So yeah, so if you look at your answer choices that they gave us, all the choices they gave. So this was out because it didn't have such that. That's an element of. And this is greater than 32. 32 or bigger, 32, 33, 34, 35. So that's out. And this one says, let's see, that it's trapped between, let me make this larger. Let's see what it says. Yeah, this one says that it goes from 32 to 35. And then, oh, so they got that from, where did they get that idea from? I guess they saw this, 32 to 35. And then they say that it jumps to x equals 58. But they didn't understand what this meant. Dot, dot, dot. What does that mean? It means you include all the numbers between 35 to 58. So that's why this is the best choice here, which is what we jotted down. Okay. Okay, now we're going to go to 11. So express the set using the roster method. Okay, so here's your set that x is an element, the set x such that x is an element of all the natural numbers. And then here are your limitations, that we're looking at numbers between 4 and 12, natural numbers between 4 and 12, including the endpoint 12, but excluding this endpoint 4. Okay, all right. And now, so let me first talk about roster method. Let me give you a definition for the roster method. So let me say that the roster method shows the elements of a set by listing the elements inside of those curly braces. Okay, so then we had this set builder notation that was, this is what the computer randomly generated for me. The set X such that X is an element of natural numbers. Oops, and all our unknowns were between 4 and 12. So this one includes the endpoint 12, where this means that you exclude the endpoint 4. Okay, so when I draw that out, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me just do it. Let me do it longer. Yeah. So we've got natural numbers. So we've got so in between 4 and 12, but it's not shading. Like it doesn't include the fractions. It doesn't include the decimal. It just has the natural number. So we've got points. So we've got the point 5. So we can't put a point. Don't put a point on 4. So don't plot 4 because of this. But you can plot a point for 5, 6, 7, 8, 9, 10, 11, and yes, you can also include 12. You can also include 12 because see, it's got the underscore. Okay, so that's kind of what we're looking at. So now the roster method will show these elements. It'll list them inside with the curly braces. So then my roster method will have curly braces, and then it'll have 5, 6, 7, 8, 9, 10, 11, and 12. Yeah, but you do not have permission to include 4. That would make that wrong, okay? And you got to have the curly braces, okay? And no dots, no ellipses. It's just these natural numbers from 5 through 12. So you want to look for that. Okay. This is called the empty set. This means that you have curly braces and nothing inside it. It's an empty set. And this is wrong because it includes 4. You're not supposed to include 4 because see, it didn't have the underscore. And this is our answer here. This is what I wrote down. Okay. This one's not correct because it's got these dots, dot, dot. So this means that it would have 1 and 0 and -1, -2, -3, -4. Everything before 2. So yeah, we don't want to include that. This says after 15 to 16 and so on. So we don't want to include that. So 15 is not in there, so it stopped at 12 anyway. So yeah, the best choice is C. Okay. Okay, now let's go to 12. Determine if this set is the empty set. Okay, so we have the set X such that, and we've got all our unknowns are less than 5, and all our unknowns are greater than 5. Okay. All right. So first, let me give you some information about what the empty set is, which I did a while ago too. Let me just write something down. So the empty set is a unique set that contains no elements. So usually it's also called, I've heard it called the null set. And we also use these symbols. Like that's why if you ever write your zeros with slashes through it, oftentimes teachers will ask you not to do that because they know it means the empty set. So when you write a zero, you should just write a zero, not put a slash through it. Because if you write a zero with a slash through it, you're actually saying that those are empty sets, and you don't want to say that. But this is a symbol for the empty set. Also, this is the symbol for the empty set, which is just empty, empty, emptiness in the curly braces, nothing in there, okay? Okay, so now what we have to represent what was given to us, so what was given to me in this problem was the set X such that X was less than 5 and X was greater than 7, okay? So to represent this one, the X is less than 5. So this would be like 4, 3, 2, 1, 0, -1, -2, and dot, dot, dot. So it didn't restrict me about, it didn't say anything about in natural numbers. It didn't restrict me. Like sometimes it'll restrict you, see? Sometimes it'll restrict you and to say natural number. It didn't say that. So really, technically, here, for X to be less than 5, this kind of looks then like this. A lot of times in high schools, they do the open circle. And this book usually likes to tend to use parentheses because sometimes you have to do an interval notation. And you did some of that on test 1. That's kind of what we have, including all the little decimals and all the little fractions, okay? Okay, and then we have 7 onward. Okay, so let me do this. Okay, so we have 5, 6, 7, 8, 9. So 7, 8, 9, 10, and then it's dot, dot, dot. So this saying X is greater than 7. Okay, so again, I'm not going to use a bracket. I'm not going to close a circle. It's greater. It doesn't have the little bar. It doesn't have the underscore. It doesn't have equality. So this means that you don't include. So you exclude. Don't include the endpoints. So in this case, like 5. Okay, this one, you want to exclude the endpoint 7. Okay, So that's why you exclude it. You either do an open circle or you do parentheses and you shape it in the direction you're shading. This is saying all your unknowns are greater than 7. All right, greater than 7. Okay. And so now you want to, so remember what we're talking about. So it said, so this is what we have when we have this description of this set, and you want to find out, this looks like we have, what they call disjoint sets. This looks like we have disjoint sets. So this looks like disjoint sets. So, this idea, okay, disjoint sets, where there are no elements in common. So disjoint sets have no elements in common. So when you look at the first graph and you look at the second graph, and you see how this doesn't include 5, but it goes all the way to 5 without including 5. This one, see, doesn't even have anything on 5 and 7. Starts with 7, doesn't actually include 7. But these look disjoint. There's no common elements common to both this set and this set. Okay, and so they want to know. 12 says determine if the set is the empty set, and yeah, we would say that yes, this set, yes, this set is, and it closes back up because they did close it after that. So this set is the empty set. So this is set builder notation. This over here is set builder notation. And really what you have in your set, you try to write your setup. This is dot dot dot, and this is for example, it depends how much you want to write. If you want to write like -2, -1, 0, 1, 2, 3, 4, and really it's like 4.99, right? Repeating 9s, like 9, 9, 9, 9, 9, 9. So that's like repeating, that's the idea. So you got that set. And then you've got this other set here. So I'm trying to put, I don't know, does it matter if I put a union or an or, but you do have this, let me put this gap. You got this other set that starts here like with, let's see. So it doesn't actually include 7, but it gets real close to 7. So I guess you could put like, I guess like 7.1, maybe repeating, for example, and then 8, and then 9, and then dot, dot, dot. That's kind of the idea. I prefer the graph. I prefer the graph easier. It's better, easier, because this part gets a little sticky here, right? Get real close to 5, but not actually 5. And real close to 7, but not actually 7, right? Not 7.0. So real close to that. So it's a little sticky here, but you see that that what do they have in common? There's nothing in common in these sets. So that's why this set is the empty set, because the empty set means that that it contains no elements. Yeah. So, and here was your set builder notation up here, right? Determinant of the set is the empty set. So here's our set here, and here's I like our picture of this, but empty set means that it contains no elements. So what they mean contains no, so you know this has elements in it, and this has elements in it, but what do these have in common, right? And okay, and this is what we need. It's the what you haven't been given is this is what it is. What you haven't been given is the word and. That's what it is. So and means that you have intersection. That's kind of what's missing here. This gap is the word and. That and is powerful. So let me write that down here. So and, you had the word and. So and is used, that's what it is. And is used for intersections. So what's common to both sets? Yeah, that's what we need. So and is the intersection. What's common to both sets? That's what we needed there. That's what this is. So this and right here is I need to tell you that and is used for intersections. So what's common to both sets? Yeah. So there's nothing common to both of these sets. Okay. So that's why that's why this looks disjoint. There's nothing common here. We have no common elements. And that's what I have here. Where there are no common elements. Okay. So if you don't have any common elements, then that's why this set is going to be empty, because and implies it's asking the and what's in common here. There's nothing in common. So then how do you write up your answer? There's nothing common. It's the empty set. So we have this empty set. It's nothing in common, okay? Because this had an and in it. And and means intersection. Well, nothing intersects. Like one is not going to be found in here. Two is not going to be found in here. Okay, eight's not going to be found over here. So we needed, the gap was the and. What does that mean? Intersection. Okay. All right. Okay, so let's go to the next problem. (13) says, find the cardinal number for the given set. And then A equals 2, 9, 16, 23, 31, 35. Okay, so let's see. So first let me talk about cardinal number. So cardinal number, a cardinal number, is the amount of elements in a set. The amount of elements in a set. Okay, so we have this set. What was given to me was a set A. And I have 2, 9, 16, 23, 31, 35. And no ellipses. No, there's no ellipses, no dot, dot, dot. So this is what I have, okay? Now, I mean, there might, if there's a pattern or not, I don't know, I haven't looked to see if there's a pattern or not. That's not really important, but if I can just see if there's a pattern, let me just see, I'm curious. So if I do 9 minus 2 is 7. So if I try to say plus 7, 2 plus 7 is 9. And if I try to say 9 plus 7 is 16. And if I try to say 16 plus 7 is 23. And 23 plus 7, 23 plus 7 is 30. And they said 31. Okay, so I was just trying to see, like we did on problem number 1, was there a pattern? And there's not. And that's okay. They don't have to have a pattern in this set. They're the author. They're creating the set. And so now you know that this one actually should have been plus 8, I think. This I think was plus 8 because 23 plus 8 is 31. And then this is 31 plus 4 is 35. So there is no pattern. Okay, we have no pattern. Okay, so that's just an aside. They're not asking about a pattern like they did on problem number 1. This is just an aside. Like a side note, And aside means, and that's a side note, okay? All right, so, but going back to cardinal number is the amount of elements in the set. Well, how many elements are in the set? So this is like member number 1. This is like member number 2. This is like member number 3. This one is member number 4. This one is member number 5. And this looks like this is member 6. 1, 2, 3, 4, 5, 6. So for us, our cardinality is 6. So, and it did say A. Okay, so our set A has cardinality 6, and why is that? Because there are 6 members in set A. And the way they write up cardinality is they make use of this. For example, and N stands for the amount. Or this whole thing, the amount of members in a set. So, and this is like the name of the set. Like this is, our name was A. So it could be N of B if the set were B. N of C, N of D is the name of the set. So our set is A. So we write N of A equals 6. That stands for cardinality. Cardinality. Okay? So that's what 13 is about. How many members are in the set? Okay, and then here's some more, here's another cardinality, number 14. 14, find the cardinal number for the given set. So A is equal to 2, 5, 8, dot, 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 and then 35. Okay, so then it looks like this one then would have to have a pattern then. Because see, it's got those ellipses, dot, dot, dot. Number 13, it didn't, but this one does have those ellipses, dot, dot, dot. So we should be able, we're going to have to do some work on that. So if I do 5 minus 2, that's 3. So 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. Okay, so let me do this. So you do have to show some work for this. So 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. 17 plus 3 is 20. 20 plus 3 is 23. 23 plus 3 is 26. 26 plus 3 is 29. 29 plus 3 is 32. 32 plus 3 is 35. And I just ran out of room. I wish I hadn't run out of room, but I did. Yeah, so I better write it again. So A is 2, 5, 8, 11, 14, 17, 20, 23, 26, 29, 32, 35, and then that's it. Okay. So, and then again, the name of it is A. If it had been B, I would have said N of B. C, I would have said N of C. But this is again the set A. So N of A equals, and so I'm going to count. We want the amount of elements in set A. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like we have a cardinality of 12. So set A has cardinality 12. Okay, so this right here is member 1, whereas this right here is member number 12. So member number 1 all the way through member number 12. Okay. Okay, so let's go to 15 now. So 15 says, answer the following questions about the given sets. Are the sets equivalent? Explain. Are the sets equal? Explain. And here are 2 sets. Okay, so we need some definitions, equivalent and equal. Okay, so let me write those down. Let's see. So first, let me start with equivalent sets. So equivalent sets have different elements, but have the same amount of elements and I'm going to say let's see. I'm going to say also the coin sets have different elements but have the same amount of elements. They have the same cardinality. They have the same amount of elements, which, you know, amount of elements has to do with cardinality. So they have the same amount of elements. So in other words, the same cardinality. Okay. So I'm going to emphasize the same amount of elements, the same amount of cardinality. I'm going to emphasize that more so than have different elements. I'm kind of hesitant about saying they have different elements, but they have the same amount of elements, the same cardinality. So if I go back to my sets on 15, I had 10, 10, 10, 12, 12, 14, 16, 16. And okay, I guess that's kind of why they say different elements, because when you see this set, all these tens, all these repeating numbers, yeah, you don't want to count that as a cardinality. You don't want to count that as a cardinality. I'm going to say that's probably why they said that, different elements. So probably because duplicating elements, any duplicating elements are counted as one element in a set's cardinality. That's probably why they say that. So that was kind of the reason why. So different. So note that any duplicating, meaning repeating elements, those are going to just be counted as one element in a set's cardinality. So in your notation then for A, n of A, so that means here we're going to count this as 10, 12, 14, and 16. 1, 2, 3, 4. So we're going to say n of A is 4. Don't say this. Don't say n of A is 1, 2, 3, 4, 5, 6, 7, 8. Don't say this, because this is wrong. It's not 8. It's 4. Okay, I'm going to box that. Okay, so what about the other set? Let's see, what was the other set? Was B? B was 16, 14, 12, and 10. Okay, so then I can do N of B, finally, N of B, a different cardinality. So remember these are cardinalities. This is cardinality. Okay, that's amount of elements in your set. So B has 1, 2, 3, 4 also. B has four elements. Just like this one had 4 elements. 4 elements in set A, 4 elements in set B. Oh, okay, so then that means I can say that N of A equals N of B, which equals 4. And so therefore, these are equivalent. A and B are equivalent. The sets, therefore, the sets A and B, they are equivalent. They have the same cardinality, namely 4. Okay. All right. And I'm looking at my answer key, and so, and they're green too. See, the sets are equivalent because N of A equals N of B. Yeah. Yeah, so just be careful with this, the word different. At first that was throwing me off a little bit, the way they have that equivalent sets have different elements. But this is okay, because see, this has, but have the same cardinality. That's stronger. And so I'm underlining the cardinality on that. So that's okay. And in a way, this one has a little bit more anyways. He's got these 10s and 12s, but no, we're good on that, okay? All right, so now there's another definition besides equivalent. The other definition was equal. Equal. So equal sets have exactly, have precisely, precisely the same elements. So the same members upon close examination of each set. Even though the members can be out of order. And so we use the equal sign to show we use the equal sign. I'm gonna just stop there. We use the equal sign. Stop there. Yeah, so when you look at set A basically, if I put it from smallest to largest, I have 10, basically 12, 14, and 16. And when I look at B, it's out of order, but if I put it from smallest to largest, I have 10, 12, 14, and 16. So upon careful observation of these have exactly the same elements. Okay. They both have 10, they both have 12, both have 14, they both have 16. So that's how come we can say that therefore the sets A and B are equal. In other words, they have the same elements, namely 10, 12, 14, and 16. Yeah, so if you look at the way they wrote up the answer there, the sets are equal because A contains the exact same elements as set B. So I have the same, I like the word exact, elements. Sets A and B are equal. They have the same exact elements, and the elements are 10, 12, 14, and 16. So yeah, so you have to be specific, and you have to decide whether they're equal or not, and if they, you know, you have to explain why. You just can't say they're equal and leave it at that, or they're not equal and leave it at that. You're gonna have to, on your paper, be ready to explain why on your paper. Okay, so these have the exact same element, so they're equal. Okay. Okay, let's see. And then there's another practice problem, 16 and 17. Wow, so there's two more like this, practicing this vocabulary. So 16 and 17. So let's do that. So 16 says, answer the following questions about the given set. Are the sets equivalent? Explain. Are the sets equal? Explain. Okay, and then here's how they're putting our two sets down. Okay, so this set notation, the set x, such that x is a natural number, and then you've got the numbers between 11 and 14. You're including the 11, but you're excluding the endpoint 14. And again, it's no decimals and no fractions, it's just the natural numbers. Whereas the other one, B, again, natural numbers, and it's everything between 5 and 8, but you want to include the endpoint 8 because of the underscore, but you don't want to include the endpoint 5 because there's no underscore. Okay, so let me write that down. Okay, so for that one, let's see what they would look like. And let me do a graph first. Let me do the graph first for that. Okay, so let's say 0 is over here. Okay, so 11, 12, 13, 14. So you're going to include 11. There's an underscore. So you want to include the endpoint. And then you want 12 and 13. But don't put a point on 14. Don't plot 14 because see there's no bar, no underscore. Okay, so A is 11, 12, and 13. Okay, now let's check out B. B was the set X, and X was a natural number. And then it's got this written down. Write that down. Okay. All right. So here we want to include an endpoint 8. Okay. But here you want to exclude that endpoint 5. Okay. So again, I'm going to start with a line graph. And let's see. So 0 somewhere over here. So I have 5, 6, 7, 8. So I don't plot 5 because there's no underscore, but you can put a point for 6, 7, and you can put a point for 8 because it does include that endpoint. Okay. Okay. So then B is 6, 7, 8. All right. Okay. So now we've got our 2 sets. Okay. So let's do the cardinality for A. Okay, remember that stands for cardinality. Okay. Amount of elements in its set. Okay. So A, if I count, look, 1, 2, 3. There's 3. 3 members in set A. Okay. Okay, now let me do cardinality for B. How many members are there in set B? Okay, so look, 1, 2, 3. Ah, okay. So remember what we said about equivalent. Remember we said equivalent sets have pretty much the same amount of elements, the same cardinality. So I'm going to write that down. Yeah, and that's what's happening here. N of A has 3 elements and N of B has 3 elements. So I would say that sets A and B are equivalent. If I look at my answer choice for 16, the sets are equivalent. And then why? Because the cardinalities are the same, namely 3. I'm going to write that down. So the sets A and B are equivalent because their cardinalities are the same, namely N of A equals N of B equals, for us, 3. All right. Okay, now the other question about whether the sets are equal or not, we want to know if they have the exact same elements. So let's see. A, what was A again? A was 11, 12, 13. B, what was B? 6, 7, 8. And I was going to try and draw a line. Like I was going to try and draw a one-to-one line. But I can't because they're not equal. They don't have the same elements. And you can see how the write-up says the sets are not equal because set A does not contain the exact same elements as set B. Okay, so I write that down. So the sets A and B are not equal because, can you see how they write? They don't have the same elements. And they say, yeah, set A does not contain the exact same elements as set B because set A does not contain the exact same elements. Yeah, and I think I had used the word precisely, but I like exact. Yeah, originally I said equal sets have exactly the same elements, precisely the same members, right? Upon close examination of each set, even though the members can be a little bit out of order, but you put them in order and you check them out. So the sets A and B are not equal because set A does not contain the same exact same elements as set B. And you can see I'm not able to draw a line and connect them. Like I was able to do that for the previous one. See how I stacked them? See how I matched them? See that? Can't do that here. Okay. So you have to be able to have an answer and then justify it with something that's reasonable, that has to be justifiable. You just can't put anything. It has to relate to the definition of what you're doing. Okay, definition. Okay, so let's do 17, which is another one like this. Yeah, so another one like this. So are the sets equivalent? Are the sets equal? And then here are your sets. Okay, so let me write down A. Let me write down B. Okay, so here's A. 2, 2, 2, 4, 4, 6, 8, 8. Okay, so really that's, remember we shouldn't repeat them. So that's really looking at 2, that's really looking at 4, that's really looking at 6, and that's really looking at 8. Okay. So then if I do my cardinality, n of A equals, and I shouldn't count them twice. I don't count, don't count repeating items. Repeating items should only be counted once. Repeating elements should be counted only once. Okay. So when I do my cardinality, I say 1, 2, 3, 4. Okay, now let me look at B. B was this. 8, 6, 4, 2. Okay, so N of B, which is card, remember that stands for cardinality, which is amount of elements in a set. And remember that you can only count them once. If they repeat, you can only count them once. So for us B, I have 1, 2, 3, 4. So we can say that A and B are equivalent. They have the same cardinality, which is namely 4. So if I look at my write-up for that, it does say the sets are equivalent, and see, n of A equals n of B, and you should also write, which is namely 4, equal to 4. Okay, so the sets A and B are equivalent because n of A equals n of B, which is equal to 4. So see, you're justifying. You're answering them, are they equivalent or not? And then you're telling me why. And you're using the definition. See, this stands for cardinality. This means cardinality. The cardinality of A is the same as the cardinality of B. And what was it? You're telling me that it's 4. Okay. All right. So then the other thing is about equal sets. So again, let me stack them. So A, I have basically, if I put in order 2, 4, 6, 8, and then I have B, put it in order. See, they're out of order, so I'm gonna put them in order. 2, 4, 6, 8. And then look, I can do this like 1 to 1. See this 1 to 1 arrangement there? That's precisely, exactly the same. Yeah. So we're going to say A and B, these sets are equal because they have the same exact elements. And you can see in the write-up, that's what they say. The sets are equal because set A contains the same elements as set B. And the keyword is the exact same elements as set B. And then you can also put what they were, namely, what were they? They were 2, 4, 6, and 8. That's what I did on 15 when I did 15. that 15 had the same exact elements, and I did put down what they were. See, yeah. Whereas 16 didn't. 16 didn't have the same elements, so you just say they don't contain the same elements. See, I'm not able to draw a line to match anything. Okay, now I'm going to go to 18. Okay, this is what 18 says. Let's see. So notice these two figures, and they almost look identical, except one has a slash through it, which means not. And these are the word for this, the word for this is a subset. So you want to learn this means this is a subset. This means that this is not a subset. So very important. So let me start by talking about the definition for subsets. Let me start off with that. Okay. So let me say this number. What number was this? 18. This is 18. Okay, so this means, for example, this means is a subset, and this means is not a subset. Okay, so now let me give you the definition for a subset. Let me use my pen. So I'm going to say that I'm going to use generic A. So let me say A is a subset of B if and only if, and sometimes in math books you'll see this, IFF means if and only if every element of the first set, which our case, I was making the first set A, if it's the first set is in the second set, which in my definition I'm calling B the second set. Okay, so this is the first set. This is the second set. So A is a subset, and again, the symbol for subset is this. So I'm going to learn that. A is a subset of the first set is a subset of the second set. So A is a subset of the second set if and only if every element of the first set, A, is in the second set, B. Okay. So they often call B the parent. They call B the parent set, and they also sometimes can call A the first one the child. The child also. So kind of like that reference. So B is the parent set. Okay, so let's see. So 18, if I look at 18, this is what I have. I have they didn't name it, but here's the first set, -3, 0, 3. And then here's the second set, -3, -1, 1, 3. Okay, so they didn't name it, but you could call this A and you call this B, or you could say this is the first set, this is the second set. You can call this the parent set. This is, no, sorry. This is the child set, where this is the parent. So that's what I was using earlier. Okay. But we want to know is every element in the first set in the second set? So again, I'm gonna show my work doing the stacking thing. So the first set is -3, 0, 3. And then the second set, and this is in order. I'm gonna put an order. So this is an order. The second set, I'm going to put in order, and I think it's already in order. -3, -1. Yeah, it's already in order. Okay, and I'm going to do this matching thing. So see, every element in the first set. So like -3. Is -3 in the second set? Yes. Okay, what about 0? Is 0 in the second set? Uh-oh. Right there you have an issue. Right there, you can stop right there. Now, yes, 3 is in the first set and it's in the second set. That's good, but this is an issue. This note element 0 is an issue it's a problem for this definition, because in order for this to be a subset, every element of the first set has to be in the second set. And we have an issue with 0. 0 is not in the second set, and that's an issue. So that means that this is not a subset. It's not a subset, but you have to explain that and show some work here and then write a sentence to show that. So I'm going to say that this -3, 0, 3, and then you know how that is box here. We want to do this, which means is not a subset. We're going to learn that. Not a subset of the second set, -3, -1, 1, 3. And then why? What's the issue? Because the element 0 is in the first set, but not in there with 0. -3 is in the second set and 3 is in the second set. But what about 0? That's an issue. So once you find one contradiction, you stop right there. And if I look at my answer choices, they have, you can see here they're showing that. Okay. But remember, on your test, you have to show your work and explain, write a sentence to justify your answer on your work when you submit and upload your work after. So you take your test, you submit it in Canvas, right? And then you have 50 minutes to turn your work into a PDF, and then you upload it in the next relevant assignment in Canvas. Okay, so we never send instructors PDFs of your work in email. Everything has to be uploaded, and we're trained to upload it in Canvas. Okay, all right. And then just remember when you're recording yourself, remember don't be in a bed, don't be reclining, be at a flat surface, at a desktop, flat surface, and keep, like right now, I don't have the distance here, but I want to be able to see me writing. So when you're taking the test, you have that face detection and you do the environment check, and I need to be able, to see you writing, right? And so we have you recorded so that we will make sure there's not another person in the room who's going to be helping you on the test. So yes, if you have small children and your children, they cling to you and they're little, they want to be near their mom and dad. So that's okay. You can have little ones in the room, give them something to play with so you can still concentrate on your test. Because otherwise they'll be, if you put them in another room by themselves, they're going to be crying. They want to be with their parents, right, with you in the room. So they can be with you. You just can't have people in the room who can help you on the test. So you can't have another individual, an adult old enough who can be helping you on the test. So that's what we don't want. But then I also want to be able, you're supposed to put your phone in a school box or in a bag and put it out of sight until you're submitted, and then you take it out for a PDF, right? And then, yeah, and then, and then you're writing in this environment. It's really better if you have a webcam that's portable, because those people who have webcams that's portable, they can put it on a bookshelf or on a chair, and I can see them right on the side. And some people also, they have a dresser, like they're in their room and they have a dresser or a vanity, and so I can see that awesome spaceness, like the 6 inches between the person. That's why I was having you set it up. That what would we say, that landscape portrait and landscape portrait, where you got that distance where I can see you. So work on that, because right now the way I have it set up is not ideal, because I don't have that 6 distance. I'm more like a landscape. I need more diagonal or distance. Okay. All right. Okay. All right. So we finished 18, and I see that 19 and 20 or more practice for that. But I'm gonna take a break. I'm gonna take a break, and so I'm gonna stop recording, and then I don't know how long this will take to get ready, but I'll put it up as soon as it gets sent to me in my email. I'll put that up for you so you can start reviewing that, and then after I take my break, then I'll record again and start working from 19 onward. Okay. So we do have 38 problems. So I'm about halfway there, and that was my intent, to stop about halfway, give or take. So yeah, we'll stop here at 18. Okay. All right. Okay. So take care and work on your math, and see you in a bit then. All right. Stop this then.